Okay, so now here's number 2 on practice test 9. This is made in summer 1 of 2019, just for those of you keeping track. So this is the integral of a rational function, so it makes sense to try partial fraction decomposition. And to do that, we need to first decompose this rational function, and we'll do that by splitting up the denominator and then rewriting in the general form. So that's a over 2x minus 1 plus bx plus c over x squared plus 1. We'll clear out the denominators by multiplying on both sides, and we'll get this mess, and then when we multiply it out, we'll get ax squared plus a plus 2bx squared minus bx plus 2cx minus c. Now, this equality needs to hold for all values of x, which means that the coefficient for x squared needs to be the same on the left and right, the coefficient for x needs to be the same on the left and right, and the constant needs to be the same on the left and right. So if we look on the right at what the coefficient for x squared is, we'll get this system of equations. And we could solve that directly using techniques from, I don't know, like Algebra 2. But we also have one more trick up our sleeves. So we can let x equal 1/2. And then when we plug that in, because 1/2 is, well, a fraction, we'll get something ugly but still doable. And the bx plus c term will be multiplied by 0. So that makes this one equation, one unknown, so we can solve for a right away. Now we can plug in 3 for a. And now we have b in an equation with no other variable and c in an equation with no other variable. And so we know a equals 3, b equals 1, and c equals -3. And that means we can rewrite this integral in the following way. And that x minus 3 over x squared plus 1, it's more convenient to split up the numerator in this way. And now we know how to integrate each one of these pieces here. So the first two are just going to be a simple u sub. And the last one is just -3 times arctan. And then don't forget your constant of integration.